Okay, so what if I told you that you already use the scientific method all the time, probably without even realizing it? Today, we're going to talk about how to level up that skill, how to transform our everyday guessing into a really powerful, systematic way of knowing things for sure. Let's get into it.
So let me ask you something right off the bat. When you run into something you don't know, what's your gut reaction? Are you the type to make a quick guess based on a hunch? Or do you kind of hold back and look for more information before you decide? Well, by the end of our time here, you're going to have all the tools you need to be a knower in pretty much any situation. To get us started, we're going to solve a little mystery. And I mean, it's a really simple one, a puddle on the floor. Now, I know that sounds super boring, but trust me, how you deal with this puddle says everything about how you think.
Just picture it. You walk into your kitchen, maybe to get your morning coffee, and bam, there it is, a puddle of water sitting right there in the middle of the floor. What is your immediate thought? What's the very first thing you do?
See, this is the moment where we all face a fork in the road. The everyday thinker just leaps to a conclusion. The dog must have spilled his bowl again, right? Case closed. But the scientific thinker, they stop. They don't guess. They ask a simple but incredibly powerful question: what is the evidence? And that single difference, that one little pause, is the key to everything we're going to talk about.
So let's put some names to these ideas. We're really looking at two totally different ways of approaching the world. We've got the regular way, which is kind of our default setting, and then we have what some call the starborn way, which is all about scientific inquiry.
And this table just lays it all out so clearly. The regular way, our everyday reasoning, it runs on intuition, on what we've always been told. The starborn way demands evidence you can see and measure. And notice the speed difference. Everyday thinking is fast. It's all about jumping to conclusions. Scientific thinking is slow. It's careful. But here's the biggest difference, the one about bias. The regular way is always looking for proof that you're right. But the scientific way, it's actively looking for ways to prove you're wrong. One is messy and random. The other is planned out from the start.
Let's make this super real. We've all been there. You get sick and your grandma says, drink this special ginger tea. It'll make you feel better. So you drink the tea and you also get like 10 hours of sleep. The next day you feel amazing. So was it the tea or was it the sleep? If you don't separate those two things, you can't really know which one did the trick. It's such an easy trap to fall into.
So the big question is, how do we avoid those traps? How do we build this stronger, more reliable way of knowing things? Well, it all rests on three foundational pillars. These are the bedrock of what it means to think like a scientist. And here they are, the three non-negotiables: structure, replicability, and empiricism. If you're missing even one of these from your investigation, you're not really doing science anymore. You're just telling a good story.
Okay, first up, structure. This is huge. Real science is the total opposite of just messing around. You have to have a question, a method for answering it, and a whole plan laid out before you even start. That plan is your roadmap. Without it, you're just wandering in the dark.
Now this next one. This might just be the most important idea in all of science. Replicability. This is the ultimate test. It's simple. If somebody else, somewhere else, can't follow your exact steps and get the exact same result you did, then what you found isn't reliable. It's not a real discovery. I love this idea. The recipe rule. Think about it. If you bake the most incredible cake of your life, but you can't write down the recipe so someone else can make it too, then it wasn't a discovery.
It was just a happy accident. Science is the recipe. It has to work for anybody who follows it, every single time.
And our third pillar is empiricism. It sounds complicated, but all it means is that your evidence has to be based on observation. You have to be able to see it, count it, or measure it. Saying, I feel like this magnet is really strong, that's just a feeling. But saying, this magnet can lift 50 grams of iron, now that is empirical evidence. It's a fact.
All right, theory's over. You've got the tools. You know the 3 pillars, so now let's put them to work. It's time for a little case study, the case of the wilting plant. So here's the deal. You've got 2 plants. They're identical. They're side by side. Plant A is green and happy. Plant B, not so much. It's yellow, it's wilting. The everyday thinker might just say, oh, the plant is sad. But a scientist, how would you, with your new tools, solve this mystery?
Well, you'd use structure, right? First, you'd just observe everything really closely. Then you'd form a very specific question. You'd compare the 2 plants systematically, looking for the one thing that's different between them. Then you'd design a little test to see if that one difference is the cause. And only then, after all that, would you conclude anything.
And in this case, your structured observation reveals the answer. The sunlight's the same, the temperature is the same, the pots are the same. The only difference, the single variable, is that plant B's soil is soaking wet, while plant A's is just damp. Suddenly, your question gets way sharper. Is it possible plant B is being overwatered? Now you have something you can actually test. And that right there, that ability to go from a vague problem like my plant is sad to a testable question like is it being overwatered, that is thinking like a scientist. And honestly, it's like having a superpower that lets you cut through all the noise and find out what's really going on.
Here's a really fun way to practice this. It's called the Martian test. Imagine you have to explain how to make a peanut butter and jelly sandwich to a Martian who has 0 common sense. A bad instruction is just put some peanut butter on the bread. The Martian might literally put the entire jar on top of the loaf of bread. A scientific instruction is precise. It's replicable. It leaves nothing to chance. It forces you to see all the assumptions you make every day.
And this really brings us to the most important point of all. This whole thing, it is not about being a genius. It's not about being the smartest person in the room. It's about being honest and being careful. I love this quote. A careful student is a better scientist than a careless genius. It's a skill you build, not a gift you're born with. Anyone can do this.
So here's the real takeaway. This way of thinking isn't just for people in lab coats. You can use it everywhere, every day. Which brings me to my last question for you. What's one common sense belief, one thing you just know is true, that you're going to question today using these new tools? Maybe it's a diet trend, or a political headline, or even just some advice you've always followed. The power to actually know is right there, waiting for you.